Good morning.
Well, I do like big sound, but it's just I don't really do very well there. I just have to make it. Yeah. I always go on docs because I can't find stuff on people. I always do, but I just can't find the logo.
Yeah.
Where's your notes? You did?
Yeah.
Yeah.
Well, I kind of skipped like the last 5 minutes of it because I didn't want to do
The last
that.
1 minute was just like questions.
I just skipped that last part.
I'm gonna be honest.
I did all the stuff that I could on a doc and then also with this picture.
Yeah, that's what I did. But why do I keep assigning videos? Like literally, my math teacher like assigned like 3 or 4 videos to watch.
Did they not teach it?
No,
They just give you the
they
video?
just give you the video.
Yeah, I had to do that for AP stats. He just gave me they were like, or they were just like videos. Like, how am I supposed to learn from that? This is nice here. What?
Just AP stats.
Yeah.
Both
Both?
this year?
Oh. You got flash?
Yeah, because Savannah
Oh,
did it.
like
And
like
so, remember how Mr. Lowe wanted us to learn about coding and stuff?
you do coding?
We did coding
Oh.
in 8th grade
And
for like 3 months.
we didn't even do that.
We didn't do
I
anything
didn't
in
do
8th grade, if I'm really
No,
being honest.
kind of classes you just said don't like do anything. I don't know. That was a weird year. We had like this whole class with a bunch of people and it was supposed to be like accelerated. We didn't really do anything. It's supposed to be geometry and I know absolutely nothing right now about it. In 8th grade, you had people from
Yeah, that was like Amy and Laura.
Yeah.
Yeah.
It was in high school. And they were
That's, we had like a whole class for that.
when they were in 8th,
Like in 7th grade, we like needed to algebra and geometry, and 7th grade combined, and then we did advanced algebra. Yeah, but I don't know if it's even
no, it didn't.
we only had like. I'm fine. You took notes on the amount of it, see why you're running.
What do you mean on that one?
See, like, steps for finding protons and neutrons. Atomic number tells you the number of protons. Yeah, but that's what I wrote. Like, I wrote 4 fundamental forces. Periodic table, blue numbers are like the stuff I wrote.
I just wrote down everything.
I drew some pictures.
Yeah, I drew it. Yeah.
I don't really want to pay, but
Is anybody?
I don't get, okay, who keeps calling me? I've gotten 3 calls in the last 2 minutes. No, it's like Oregon and El Paso, Texas.
Yeah, probably spam text.
Oregon,
Yeah, they changed their location.
but it's a different number.
Yeah. Is it at 608?
608 when it was 915.
Good morning, Karen. How you doing?
Doing all right. Oops. How you doing, Maria? Doing all right. Lily, how you doing? All right. We got Morgan and where's RJ? There you are. Sotera and Mike. There you go. Andrew? No, you're Lars. Let's see who else do we got here. All right, let me just finish taking attendance and then we'll start. Let's see. Almost ready to start here. I don't see All right, we're ready to start. I'm just gonna switch over to the iPad and then we'll get started. It's up to you if you want to join the Zoom or not join the Zoom. All right, just a reminder, I'm going to have this playing in the classroom, so anything you put in the chat room is visible to everybody in the class. All right. So first of all, I hope that things went well yesterday with the video. I'm sorry that that was the day that my shot came up, but what's worse is that I showed up for my shot and they said they ran out of the vaccine. So I got to go back today. Okay. But I'm not leaving today. I made the appointment. I was able to make the appointment later in the day. So hopefully I'll be fine, but I'm planning for lessons tomorrow just in case I'm not here. So that kind of sucks. The other thing that I was going to say is bring, let's see. No, you don't have to bring. So we'll have our first lab next week, Tuesday. Okay. So the lab won't have anything to do with what we're learning because it's first semester labs, but we'll walk through it and review it and we'll do the calculations together in class because I know it's been a while since you doing that stuff. So you probably forgot a little bit. Okay. But for those of you at home, make sure you bring your iPads and your earbuds tomorrow, just in case if I'm sick and not here, then you'll be ready to go. Okay. Probably muted. Nope. Any questions at home before we get started? All right, so what I always like to do is I like to start off with the objectives so that you know what the point of today's lesson is. So you don't have to write the objectives down, but I think it's always a nice thing to say, okay, by the end of today's lesson, you should be able to balance alpha, beta, and gamma reactions. I don't know that we'll get to it, but also define fission and fusion. Now, all these objectives are on the front page of your nuclear packet, and I will upload that today. For those of you who are completely virtual, I started uploading stuff already into Canvas. The handouts are in there. Your first homework assignment is in there. So for tonight, your homework is nuclear worksheet number 1. Okay. It's due at 10 a.m. Okay. Even though I'm giving you paper copies, you still need to upload to Canvas. Okay. So it's up to you if you want to do the homework on paper and take a picture, or if you want to put it into Notability, and you're gonna have to take your earbuds out. Or upload it into Notability. It doesn't make any difference to me. Same thing, it doesn't make any difference if you take notes on paper or if you take notes on your iPad, okay? Any questions at home, you guys, about what your expectations are? Maria? Maria. All right. All right. So let's go through, let's start with alpha. Like I said, alpha, the symbol for alpha is the Greek letter like that. It's like we call it the fish. And it's got an atomic mass of 4 and an atomic number of 2. Now, I think it was I should look this up. I think it was the first one discovered. And so they called it alpha, you know. Later on, they realized it's just the helium nucleus. So 4,2 alpha is the same thing as 4,2 helium. So let's do our first example, and that is radon. So you watched this in the video yesterday. So give me a thumbs up if you think radon is radioactive. That goes for you guys in the classroom too. Got a question? Laura? Oh, I was gonna say thumbs up. Thumbs up if it's radioactive. Now, how do you know that that's radioactive? Because in the video yesterday, it said anything above 82 is automatically radioactive, right? So radon is element 86. So it's automatically radioactive. It's automatically unstable. The number on the top has to be given to you. Okay, Abraham? When you do your homework, the top number has to be given to you. The bottom number you can look up on the periodic table. So when you look at radon, the atomic number is 86. So that you can always look up. So that's how I got radon to be 86. Okay. Now what's going to happen is when it goes through alpha decay, it's going to produce an alpha particle, Zoe. And an alpha particle is 4,2 alpha. Now you can write it as 4,2 alpha, or you can write it as 4,2 helium plus 2. So it doesn't matter, Emma, which one you do. If you want to write it as helium, that's fine. Or if you want to use the alpha symbol, that's fine too. Now there's really only one rule in all of this stuff, Audrey. And that rule is the numbers on the top have to add up and the numbers on the bottom have to add up. Okay. So we're only gonna do alpha, beta, and gamma, Audrey. But if you were ever to go on and study K capture or neutron emission or positron emission, the rule is the same. The numbers on the bottom have to add up, the numbers on the top have to add up. So all we gotta be able to do is addition. So 2 plus what number equals 86? 84. All right. And then we go try to figure out there, Cecilia, what is element 84? So you look at your table periodically and you look for element 84. Element 84 is polonium. And then the numbers on the top have to add up. So what we have here, Karen, is 4 plus what number equals 226. So then you got to make sure the top numbers, Lars. Yep, question? That's all right. So then the top numbers have to add up as well. So 4 plus what number equals 226?
222.
222. That's the only thing you really got to remember with any of these things. The top numbers got to add up, the bottom numbers got to add up. So that's alpha decay. All right. I can show you a picture of this. And these pictures, some of them, I've got almost all of them uploaded. Here's a picture of alpha decay. And what you see is on the side over here is some of the protons and neutrons came shooting out of the nucleus. You'll see that this part is missing right here. Okay, so they came shooting out of the nucleus. That's what alpha decay is. So it's a little particle flying through the air. So we should be able to detect that. So what I have here is alpha sources, radioactive polonium, okay? And because the alpha particle has a charge, anything that has a charge should conduct electricity. So I've got a Geiger counter. The Geiger counter has a piece of metal here. And when the alpha particle strikes that Geiger counter, it should conduct a small electrical circuit and we can hear a little beep, okay? So I've got my radioactive polonium. The radioactivity is actually on the other side. And we should be able to detect some radiation. So those are those little alpha particles hitting the Geiger counter, okay? Now it's hard, you can't see them, they're too tiny, right? So what you can do in order to see them is create a cloud chamber. Now, I have never had good luck doing this, so that's why I'm just going to show you a video.
Frostbite Theater presents.
So you got to get methanol
70% isopropyl alcohol.
and get dry ice. Get your radioactive
Except for
source.
small amount, you don't need a license.
So
or
at the very
permit to-
tip of that needle is radioactive polonium. Now, do you know what a cloud is? A cloud is condensed water, right? When you look up in the sky, you see clouds. So as the alpha particle flies through the air, it's going to cause the methanol to condense. So you should see a cloud form. That's why it's called a cloud chamber. So they put the alcohol in. They're waiting for it to get cold. And you're going to see the alpha particles shoot out of the tip.
We'll kill the lights and light up the chamber from the side with a flashlight. The dry ice is cooling the air inside the petri
Those
dish.
are the alpha particles
As the
flying
air
out.
gets cold, it can't hold as much alcohol vapor. This is kind of like what happens when you go on a cold day. You see clouds because the cold air can't hold all the water vapor that was in your warm breath.
So even
As
though
the
they're
source-
invisible, there are ways to make it visible. Okay. Now, alpha particles are pretty weak. I should be able to block it with just some paper. So the radiation, it's paper is just blocked, a little bit's getting through. But for the most part, paper blocks it. So alpha is the weakest. And Chloe, it can be blocked by air or a thin piece of paper. Beta, I'm guessing, was the second one discovered. And it's the same thing as an electron. So they didn't know it at the time. And that's probably the reason why they don't just call it an electron ion, is because they didn't know it was an electron. So they called it the beta particle. So I always put a line through my zeros so I know they're zeros. Otherwise, you might think it's oxygen. So in science, you typically put a line through your zeros. So with beta decay, the neutron turns into a proton. So with beta decay, a neutron becomes a proton. And an electron is produced. But we know an electron is also called a beta particle. So it's up to you, Andrew, if you want to write beta or if you want to write electron. Okay. And then so you know already of three particles. You know of neutrons, protons, and electrons. You've heard of those. You learned about them in middle school. There are other particles. There are things called quarks. There's an up quark, a down quark, strange quark, charm quark. There are things called mesons, baryons, leptons, and antineutrinos. They're all different types of particles. We don't need to study them, RJ. If you go on in science and you go to quantum physics, you'll study them. For us, we don't care about them, okay? But they exist. And when you go through beta decay, you produce one of these other particles called an antineutrino. You know, it's like, do we really care about it? No. But I want to be honest and say, okay, that's what's made. And the symbol for it is like a letter V with a line over it. That's the symbol for antineutrino. But that is the correct equation for balancing beta. A neutron becomes a proton, an electron, and an antineutrino. So that's what happens during beta. So let's do an example of this. Let's do radioactive iodine. So iodine 1. Now, Keith, iodine is element number 53. So iodine should not be radioactive because it's everything under 83 that's radioactive. But if you remember from the video yesterday, you can make things radioactive by giving them the wrong number of neutrons. So iodine would like to be iodine 127. That's its stable form, okay? It wants to be 127. Instead, it's iodine 131. That's radioactive iodine. And you will inject someone with this if you want to like check their veins and arteries to see if they're clogged. So maybe some of you have been injected with radioactive iodine, maybe not. You have?
Does it matter to make it radioactive if it's under what it wants to be or the?
So the question is, doesn't matter. So if it's over or under, doesn't matter. So iodine wants to be 127. That's its most balanced nucleus, okay? So whatever the closest whole number is, that's what it wants to be balanced. So like krypton, 83.7, krypton would want to be 84 to be balanced. Now, what do I mean by balanced? So the nucleus wants to be balanced, just like a canoe wants to be balanced. So if you start adding more neutrons, it can sometimes make the atom unbalanced. Just like if you put too many people in the front of the canoe becomes unbalanced. You almost have to always put 2 people in at a time. Or if you're putting an odd number of people, you got to balance it. You know, you can't put 2 in the front and 1 in the back. You got to go 1, 1, and 1. So the nucleus is like a canoe. You got to keep it balanced. And so sometimes adding more will make it radioactive. Sometimes taking away will make it radioactive. Good question. All right. Oh, so what I was going to show you here is with beta, a proton becomes a neutron. other way around, sorry. A neutron becomes a proton, sorry, Karen. With beta, a neutron becomes a proton. And if you look really closely here, there's my neutron. It turns into a proton. And when that happens, Maria, out comes an electron. Okay? They didn't draw it here, but also out comes an antineutrino. What do antineutrinos do? They're still trying to figure that out. It's there. Don't know that there's any purpose to it, just like your little pinky toe. You've got a pinky toe, but not sure what its purpose is. Same thing with the appendix. Got an appendix, not really sure why. All right, so a neutron becomes a proton. So in other words, the atomic number increases by 1. What is element 54? Element 54 is xenon. So iodine turns into xenon. If you have beta decay, you are going to produce a beta particle and an antineutrino. Top numbers have to add up, the bottom numbers have to add up. So 54 minus 1 equals 53, right? So 54 minus 1, Sophie, equals 53. And the top numbers also have to add up. 0 plus 0 plus what number equals 131? 131. So that's beta decay. If you want to write the beta particle symbol, that's fine. If you prefer, Sophie, to write the E, that's fine too. It's all up to you. All right, Maddie, I've got some radioactive polonium. Is it polonium? Strontium, sorry, just kidding. Radioactive strontium and radioactive thallium. And they're going to emit beta radiation. This is stronger, right, Maddie? You can hear it. Now, before you get nervous, I'm going to start moving this away. So what's happening to the amount of radiation as the further I get away? It's going down. So even if there was radiation, if you just stand far enough away from it, you're okay. People freak out right away. It's like, no, I just stand enough far away from it. You're all right. We should be able to block this with paper. A lot of paper. A little bit of paper is not going to do anything. Go right through the paper. But if I add very little is getting through. So you could just cover yourself in paper, RJ, if you're afraid of radiation. Totally normal. But I suppose wearing masks are totally normal too. You know, let's see if it goes through my hand. Nope, my hand is blocking it. So beta can be blocked. It's a little bit stronger. Can be blocked by a thin sheet of metal. Or lots of paper. How you doing, Megan?
Good.
You believe any of this stuff, or am I just making it up?
Believe.
I suppose that's good. So sometimes what happens after something goes through beta, it still has too much energy. And it's got to get rid of that energy. We call it a high energy state. Okay. I like to think of it as like your little brother on caffeine. If you give your little brother a couple of Red Bulls, he's got way too much energy. That's what gamma is. Gamma, the symbol is like the ribbon, except it's upside down. It is pure energy. Basically, the less mass you have, the more energy you have. So if we go back and look at the alpha particle has a mass of 4. It's the biggest and the heaviest, but it's also the weakest. It has the least energy. The beta particle is smaller. Still has a little bit of mass, smaller, and therefore, Lily, it's got more energy. And then we get down to the alpha or the gamma particle. It's pure energy. It has no mass. Okay. Now, this is not quantum physics. We're not going to study quantum physics. Some of this stuff has very complex explanations, but the electron, if you stop the electron, let's say you could grab it in the air and stop it, and it has 0 mass. When the electron is not moving, it has 0 mass. As soon as the electron starts moving, it gains mass. So that's why we say that the electron has no mass, but it does have a little bit of mass because the electron's always moving. But in theory, if you could grab it and stop it, it'd have no mass. Okay. The gamma particle has no mass at all. It is pure energy. Now, do not ask me, Lola, what energy is. Nobody knows. Okay. Nobody knows what matter is. Nobody knows what energy is. Yet we use energy every day. We can feel it. We can study it. We can change it, but nobody knows what it is. Okay. And I don't think we ever will. If you go in the back of your book, which you don't have, but if you go look up the definition of matter, it says something that has mass. And if you look up the definition of mass, it says something that has matter. We're standing on the earth right now. We know the earth exists. We know the earth is made of matter. We don't know what it is. Okay. And like I said, Lola, I don't think we ever will, because I don't think it's possible for our brains to handle it. And I'll just give you a quick analogy why. If you were to ask yourself, what's the most important organ in your body? You probably say the brain. Okay. Now, who's telling you that? Maybe if you asked your lungs, they would give you a different answer. Or if you asked your heart. So can you objectively study something you're made out of? If you're made out of matter, how do you study matter? I don't know. Another way you could put this is, no matter how hard you try, Keegan, you cannot teach your dog algebra. I don't care if you spend 30 years, your dog will never learn algebra. It's beyond the capability. I believe it's beyond our capability to know what energy and matter is. Maybe I'm wrong, but I don't think humans will ever know what those things are. But you're still gonna have to take a test at the end of this unit. What's up with the wired symbols? Oh, the weird symbols. So we use Greek letters, and that's the Greek letter gamma. And then, so that we don't confuse zeros with oxygen, we put a line through it. Why do we use Greek? I'm not sure why they use Greek, but if you go online, you can look up the entire Greek alphabet. I believe, I'm trying to think what a capital F, they all have capital and lowercase. Like this is uppercase pi. That's lowercase pi. So next time your math teacher tells you to write pi, be a little smart aleck and say uppercase or lowercase. Stump them. All right, so with gamma, when you see an asterisk, it means high energy. So sometimes when you go through beta and you get done with beta, you just still have all this leftover energy, just like your little brother on Red Bull. And so you have to release that energy. And you release the energy in the form of gamma. So once your little brother has run around the room and got rid of all that energy, then he's just your normal brother. He didn't turn into something else. He didn't turn into a cat, didn't turn into a dog. He's now just low energy brother versus high energy brother. So the element doesn't change. It's still xenon before and after. Now it's just low energy xenon. Gamma is the strongest. It can go through pretty much anything. Can be blocked by lead. Well, yeah, it can be blocked by lead. Well, Keegan, do you think I got some gamma radiation? You bet I do. It's amazing what you can buy on the internet. This is radioactive cobalt. Now let's see if we put some paper over it. Let's see if it blocks it. Doesn't block it at all. Goes right through the paper, the radiation. How about my hand? Goes right through my hand. Blocks a little bit of it. It's not as, well, maybe it's about the same. I don't know. How about if we put it under the desk? Going right through the desk there, RJ. For all you know, I could have taped a whole bunch of radioactive pellets under your chair and you never know it. You got to look after class, aren't you? Again, the amount of radiation is pretty tiny, but let's see if we put a whole bunch of paper on it, what happens? Let's see. I'm still going through the paper. How about lead? So I took this from the dentist's office. I just walked out with it under my coat. They never know, just, so don't tell them. That's lead. It has lead in it. It's still not blocking it. That's not good. Blocking some of it. What if I put it in a lead container? Wow, it's still getting through. Less of it, but it's still getting through the lead. So gamma is a lot stronger. So the sun produces a lot of radiation. So if I just hold this Geiger counter up, I'm picking up a little bit of radiation. Now, where is this radiation coming from? A little bit is coming from the sun. Probably more of the radiation is actually coming from the concrete in this room. There's lots of concrete all around us, and concrete is going to contain, there's radioactive elements in the ground. So it's going to contain a little bit of radiation from the concrete. I've got some radioactive rocks. So these rocks are from out west. The United States has the largest amount of uranium in the ground of any country. So if you live out west, Maddie, you will be exposed to a little bit more radiation than the rest of us. So lots of uranium in those rocks, okay? The sun actually produces more radiation, but do you know what blocks the radiation from getting to us? The air, or the fancy name for it is the ozone layer. There's a special form of oxygen. We learned this in, we said oxygen must always be diatomic, right? The further you go on in chemistry, we learn all the weird stuff. There's a weird form of oxygen called ozone. It's bad when it's at ground level. It's highly reactive. So if you breathe in ozone, it'll irritate your lungs. So you've probably heard in the summertime, ozone alert day, ozone alert day. It's bad when it's at ground level. It's great when it's up in the atmosphere because it blocks all the bad gamma stuff. So if it weren't for the ozone layer, after about, if there was no ozone layer, Keith, we'd all be dead in about 2 minutes. Because the ozone layer blocks that gamma radiation from getting to us. So go home today and thank the ozone layer. And if you're already home, go outside during lunch and thank the ozone layer, okay? All right. Oh man, there's so much cool stuff we could talk about. Remind me tomorrow, because I want to make sure we do your homework. There's a movie right now called Radioactive Girls. It's like a real movie. So if you want to watch it, called Radioactive Girls, it's about the people, the women who worked in the factories during World War II and worked with radiation. Quite interesting. All right. For homework. So you're going to be balancing reactions. Let's just do 3 more. The way I look at alpha, beta, and gamma is kind of like playing chutes and ladders. If you're going through alpha, you go down 2 spots. So if you go through alpha, go down 2. So thallium would become gold. Gold would become iridium. Beta, move 1 square up. Silver would become cadmium. Cadmium would become indium. Indium would become tin. And if you're a gamma, lose a turn. Don't move, you stay there. So alpha, you move down 2. Beta, you move up 1. Gamma, lose a turn. So let's just do 3 more examples and then I'll give you time to do your homework, okay? Oh, let's see. How about we do sure, radioactive. No, let's not do that. Let's do fine, bismuth. So bismuth becoming thallium. Now, the numbers on the bottom, you can always look up. The numbers on the top, you have to be given. Okay, you can't do it if you're not given the numbers on the top. But the bottom numbers, you don't have to be given. Why? Because you can look those up on the periodic table. So every time we have class, you should have your periodic table right next to you. So bismuth is 83 and thallium is 81. So the atomic numbers you can always look up. So then the top numbers have to add up. The bottom numbers have to add up. So what number plus 81 equals 83? 2. And then what number plus 208 equals 212? And so then what type of decay is this going to be? Alpha, because it makes helium. Remember, helium is the same thing as alpha. It doesn't matter, Lily, which one you write. Want to write helium? That's great. Want to write alpha? That's good too. What about platinum 200? So platinum is element number 78. -1 plus what number equals 78? For whatever reason, Maria, sometimes people's brain just kind of go a little goofy. You know what people usually write? They usually write 77. And it's not a knock. It's just something about our brains do this. It's for the last 22 years of teaching is always this way. But obviously 77 minus 1 is not 78. So just be aware of that. It's got to be 78. No, can't even do myself. It's got to be 79, right? 79 minus 1 is 78. And that's going to be element gold. And then the numbers on the top have to add up. So you can make gold. So why don't we make gold, Maddie? Is because it takes too much energy. It's too costly to make gold. And then the last one, the gamma one, that's easiest. If you see the asterisks, you know it's gamma. So this one's beta. If you see the asterisks, you know you're going to produce a gamma particle. And then the element stays the same. It's just no longer high energy. So any questions on those three examples before I give you time to do your homework? So your homework, you go into Canvas. There's nuclear chemistry. Why doesn't it say it's published? It is published. Nuclear worksheet number 1. There are 2 pages to it, page 1 and page 2. Make sure you do both pages. And again, it's up to you if you want to do it on a separate sheet of paper or if you want to import it to Notability, but you just got to do the ones that aren't crossed out. Okay, so don't do the ones that are crossed out. So like for the first one, -1, this would be beta. Right? 14 minus 1 is 13. And the element number 14 is silicon. And then it would be 24. Well, this took me longer than I expected to get through this. So now we have resource from 12:10 to 12:50. So if you are at home, you could eat lunch and then do this. But if you're here in person, you're stuck with me. Right? Any questions before I give you time to go, or time to before you go at home? So make sure you upload this by 10 a.m. tomorrow, because it doesn't do you any good to just watch me do these problems. Okay? If you don't do them, I'm going to give you a different worksheet. So you might as well do it the first time. Plus, it's a pain in the butt to have to like find extra worksheets, but I'm willing to do it. For number 1, it does say identify the type of reaction. So the question is, do you have to write beta? Yes, you did have to write beta. So you got to write which type it is. Alpha, beta, gamma. All right. Any other questions? So I will obviously keep this on. I'm going to stop recording it.